Number 2. The resistance of a 40-mile length of a hard-drawn 4-0 trolley wire, 1.065 ohms at 20 degrees Celsius. Determine resistance at 0 degrees Celsius, resistance at -10 degrees Celsius, and maximum summer temperature, the resistance of maximum summer temperature of 40 degrees Celsius. So, with this type of problem, he did not mention about the type of materials. He only mentioned hard drawn 4-0. So far, in my experience, I only encountered hard drawn copper. So I assume that the hard drawn 4-0 trolley is made of copper. Okay, so let's assume it's copper because we all know the hard drawn copper is the common materials in distribution. Trolley wire, we have a resistance of 1.065. We can say this is our R2 and this is our final temperature 20 degrees Celsius. So we are tasked to determine the resistance at 0 degrees Celsius. Okay, so let's start with A. At 0 degrees Celsius. But before anything else, the temperature coefficient is not mentioned. Right? If we assume copper, we all know that the inferred temperature for our copper is 234.5. Now, we can derive the value of our temperature coefficient. That is equal to, using our final temperature 20, our temperature coefficient is equal to 1 all over the inferred temperature of copper, 234.5 plus 20 degrees Celsius. Finally, our temperature coefficient is equal to 0.003929,273. So that is our temperature coefficient. Let's save this to our alpha B, our temperature coefficient, so we will not be writing it anymore. Okay, going back to our problem, at our temperature, determine the resistance at temperature 0. Let's recall the formula first. Our formula is R2 all over R1 is equal to 1 plus the temperature coefficient times your final temperature minus your initial temperature. Let's check the given if we have the data. So, R2 is given, that is 1.065. R1 is our unknown. Okay, the temperature given, that is our alpha B. T2, that is our final temperature given, and this is 0. Okay, so let's solve for R2. Let's solve for R1. R2, that is 1.065 ohms. R1 is unknown. Plus our alpha B, which is our temperature coefficient, that is 20 minus 0. Okay, so finally, our R1, solving for R1, R1 is 0.9874043516 ohms. Okay, so that is the value of your R1. Okay, moving on to our letter B problem at -10 degrees Celsius. Okay, let's recall our formula again. We have our R2 over R1 is equal to 1 plus temperature coefficient, final temperature minus initial temperature. Now, for our B, our R2 will be the unknown since we have the value for our -10. So this is our unknown. About for R1, the value of R1, let's save this to alpha C. Okay, this is your R1. Okay, temperature coefficient. Your final temperature here is, what is the value of temperature here? That is -10. About for T1, that is 0. Okay, moving on. R2, this is the value of our R1. That is 0.97743516. Save to our alpha C. 1 plus our temperature coefficient, save in alpha B, minus -10 minus 0. Okay, so finally our R2 is 0.94860,655,74 ohms. So that is the value of our resistance at -10 degrees Celsius. Okay, moving on to the maximum temperature, summer temperature at 40 degrees Celsius. So we are tasked to determine our final temperature. Okay, so for your C, maximum summer temperature of 40 degrees Celsius. So let's recall our formula. By the way, our R2, we'll save this to our alpha D. We save this to our alpha D. Okay, let's recall our formula. Our R2 over R1 is 1 plus the temperature coefficient times the final temperature of the initial temperature. Okay, so our R2, that is our unknown. Your initial temperature, that would be our determined value at -10. This is our the value of R2 here. So this is our alpha D. So this is our alpha B. How about for our temperature? That is the final, that is 40 given. How about for initial temperature? The temperature of your R2, which is -10. Okay, let's substitute the value. R2, our D, the value of R2 is equal to 1 plus our B from here. Okay, plus our final temperature, that is 40 minus the initial temperature is from -10. So -10. Okay, so moving on, solving for your R2. Finally, your R2 is equal to 1.13973,268 ohms. So that is the maximum resistance at summer temperature of 40 degrees Celsius.